So not only the graph that I show you just now, okay, is in a straight line or in a one direction like that. Okay, so any graph, okay, that the curve is in one part, okay, is above the x-axis, then it shows that that is a direct current. Okay, why? Because the flow of the current is only in one direction. Okay, it's a direct current. But if let's say you see an alternating current, is one flow in upper part and another one flow in the lower part, upper part, lower part like that, that will be an alternating current, an alternating current. Okay? Can I? Okay, so this is what I've asked you to copy down just now. Okay, so for DC generator, it allows the current to flow in one direction only because of the split rings commutator. For AC generator, the direction of the current will be varies periodically, okay, because of the split rings generator. Then it can flow for DC generator, it can flow through a cannot flow through a capacitor, and AC can flow through a capacitor. So what is capacitor? You will learn more in chapter 4. Okay, in chapter 4, it's actually a storage of a charge. Then it will, when it is off already, it will help you to produce the charge back. Okay, make the current to be smooth. Okay, but you will learn more in chapter 4. Okay, don't worry about it. Okay, so DC generator, it cannot be increased or decreased using a transformer. Okay, using a transformer, which this transformer we will learn after this, right after this. Okay, for AC generator, the voltage can be increased or decreased using a transformer. So in other words, transformer only can connect to an AC generator, or it can allow alternating current to flow only. Okay, therefore DC cannot convert into AC. Okay, then but for AC, it can connect, it can convert it into DC using diode. Same, these two, okay, these two, okay, this part and this part we will learn in chapter 4. Okay, we will learn more in chapter 4. Okay, then this one, the DC generator, it can measure using a moving coil ammeter. Okay, which means that it can be measured, okay, using an ammeter. The magnitude of the current can be measured using an ammeter. Why? Because the current only flow in one direction. Same as the ammeter. Ammeter only allow the current to flow in one direction. That's why your ammeter that you have, if you will remember, you are doing the experiment, we must make sure that the wire is connected correctly to the positive terminal and the negative terminal. Okay, but for AC generator, because the current can flow in different directions periodically, so it cannot be measured using an ammeter. Why? Because ammeter only allow direct current to pass through. Okay, then for the similarity between DC generator and AC generator is it can allow produces heating effect when it flows through a resistor. Okay, resistance. Okay, so resistor is also a heating effect also. Okay, produces magnetic field through around a conductor. Why? Because both also you have a pair of permanent magnet inside. Okay, and it flow light, produces light energy when it flows through a filament. Okay, just like for example a bulb, okay, or a LED like that. Okay, and okay, so if let's say it's a capacitor, you see DC supply, the bulb is not light up. But if let's say it's an AC power supply, okay, which capacitor is connected in the circuit, then the bulb will lights up. Okay, the bulb will lights up. But if let's say you see both AC and DC, it can connected to a resistor. It can connected to a resistor. Okay, resistor, it can pass through a resistor. That's why this part, the bulb can light up either in a DC power supply or an AC power supply. Okay, can I think if let's say you want, you can draw this down inside your notebook to let you see that the difference between if let's say it's connected to a capacitor, DC cannot light up the bulb. But if let's say for resistor, both also can light up the bulb. Okay? You want to copy this down or not? One other one? Please tell me. Okay, wait. One, okay. So if let's say you want, you write this down as notes number, notes number 12 lah. This one is notes number 12. Okay, notes number 12. Okay, so while you are copying down, after that, you can write down the today's index. Okay, today, what day is today? Is 12. Okay, 12th of May 2020. You write down 3.4 transformer. Okay, this is what we are going to learn later on. Okay. So maybe today I will extract a little bit time only, okay? Because transformer actually is quite simple, okay? It's quite simple, okay? What time is your MS already? 12:30 or 12? 12:15 lah. Okay, I will try to finish it at 12:10. Okay, so your copying here, I cannot let you have much time. Okay, I let you have until 11:40. Okay, 11:40 I will stop already. Plus resting time, plus resting time. Okay. I think next week we are able to finish chapter 3 already. Okay. Then I will see how. Okay. Because for chapter 4, there are a few subtopics. Okay, chapter 4 we have 4 subtopics. Okay, if let's say the school starts, okay, I think I'm able to finish it maybe in 2 weeks time lah. In 2 weeks time for the whole chapter. Okay, so I want to ask your opinion. If let's say I'm not ask your opinion lah. We will see how first when the school starts. Okay, when the school starts, because I think you all will prefer face. Okay, I ask you lah. You prefer face-to-face teaching or online teaching? So since both, okay. So since because we still have one more chapter left for our Form 5 syllabus, okay. So I would not prefer to continue with online teaching because I feel like online teaching maybe some of you all don't understand already, but they're not asked because you don't know how to ask it. But maybe in face to face you are easier to ask. So I will plan to have our chapter 4 after the school reopen, but depends on when our school will be open. I expect it will be end of June. I expect that. Okay. Anyhow, we will see first. Maybe I will let you rest a few more weeks, then only we will start. Okay. For sure, it's 26th of May, we won't have any class. Okay, 26th of May, we won't have any class. Okay. Then maybe the week after 26th of May, we will see how first. Okay. We see whether the KPM got announced any date to go back to school. Okay. But at the moment, anyone got any problem with chapter 5 and 3 or not, which is what I have teach in online class. If you have any problem, please feel free to ask me. Okay? Please feel free to ask me. And please do all the homework that I have let you do in the Google Classroom. Okay, so time's up already. I think I will continue with 3.4 already. Okay, yes, Kasing? Okay, because today, actually I plan to do it today one, but since we short of time already and I want to finish 3.4, okay, for 3.3, we will DC circuit bottom light bulb like that. Yes, correct. Okay, you see only resistor, it will light up. Okay, it means that it shows that DC and AC, it can pass through a resistor, but for capacitor, DC cannot. Okay, for 3.3, okay, because today we short of time, okay, not tomorrow lah. Wait, next, I think we will discuss it during our revision already. Okay, okay, we will discuss it during our revision. Okay, so which means that, okay, next week, next week I only have 3.5, which is very short, but okay, then we will discuss exercise 3.3, and I will give you also exercise 3.4 today. Okay, so exercise 3.3 at the moment only pass up, no need to pass up. Okay, at the moment exercise 3.3 no need to pass up. Okay, sorry, I want next week. Okay, I want to continue already. Stop sharing. Electromagnetic induction 这个完了了。Electromagnetic induction 也完了了。不知道东西说。Okay, so now let us continue with this part. Okay. Okay, so today, now we will continue with the transformer. Okay, when you talk about transformer, okay, what will you think of? Bumblebee. Okay, other than that, okay, car, transformer is a car. Okay, Kenna is a car also lah, because everything Bumblebee and also Optimus Prime. Okay, Optimus Prime. Bye. Anyone of you can hear me? Sorry. Wait. My Zoom got a little bit problem. Okay. Can see my screen here. But I cannot see your chat though. So sorry. Now, if let's say now you want to ask any questions, you better unmute yourself, then ask me. Okay? Because I don't know why my chat cannot use. Okay? So, okay. Then other than that, transformer maybe Optimus Prime. But this is what we are not going to learn today. Okay? We are going to learn transformer in physics. Wait. Okay? So transformer is actually a device, okay, to step up or step down a voltage. Step up means that it increase the voltage, or step down is decrease the voltage of a alternating current. So which means that transformer only applies in alternating current, okay? Or in another words, it only allow alternating current to flow through it, okay? So I want you to copy this down, okay, as your notes number 1. This one, okay, transformer. Okay, as your notes number 1. Okay, then how is it able to increase a voltage or decrease a voltage on alternating current? Your primary coil is connected to an AC power supply. Okay, an AC power supply. Then the secondary coil will be connected to an output terminal. The output terminal can be a bulb, can be a laptop. Okay, actually what you are having here, okay, this one, the power supply, this power supply, this power supply. Okay, this power supply is also a transformer. Okay, it's also a transformer. Okay, your charger also is also a transformer. Okay, it's also a transformer. Okay, can okay, finish. No need, just number one can already. Who write on? Megan is it? Okay, just number one can already. This part can already. Okay, so next, we go to the next one. Okay, so the working of the transformer, okay, this one I want you to copy down everything. Okay, because if let's say any questions coming up, okay, you are using this way to explain how a transformer is working. Okay, so this actually they are using two combination, okay, force produced in a current carrying conductor and also electromagnetic induction to produce the current in the secondary part. Okay, so we have two parts. Okay, the AC power supply is connected, okay, is connected to the primary coil. Okay, this one. Okay, you have this one, VP is the primary voltage and this one is the primary coil. Okay, primary coil. Yes, number two. Okay, you write down working of the transformer. Number two, working of the transformer. Then everything you write down. Okay, then after that, the changing of the magnetic field, because here, okay, the current will produce a force in this here. Force already, and this force is cutting the magnetic flux in this transformer, which is connected to the secondary coil here. And this secondary coil, because there is a cutting of the magnetic flux in the secondary coil, then it will induce current. And the current induced either is increased or decreased, depending on what type of transformer is connected. It's a step-up transformer that is increase the voltage at the at the terminal part. Okay, at the terminal output. Okay, okay. Then usually this part we will call it as input. Okay, this one it will be output. Okay, input and output. And this is a symbol of the transformer. Okay, I know you no need to draw this down. Okay, this one no need. You just draw this one can already. But I want you to add something inside. Okay, I want you to add here. This is the VP. Okay, then this is the MP. Okay, then this is the NS, and this is connected to the VS. Okay, V stands for voltage, N stands for coil, okay, number of coils, okay. But here we will call it as primary coil and secondary coil. Okay, so the frequency of the induced current is the same as the frequency of the input current. Okay, so in another words, the frequency of your AC power supply is the same as the frequency of your input, the primary voltage produced. Okay, so here is the input and here will be the output. Yes, Vishnu? explain again. Which part? Whole page. Okay, can. Okay, like again while you are copying, I explain again Okay, so here because this one is connected to an AC power supply means that there is current, and current is current is flowing in this primary coil. Okay, current is flowing in this primary coil. So when it's flowing in this primary coil, it will produces a force. It will produces a force, and the force will flow around this transformer, to the secondary coil here. Okay, to the secondary coil here. And because this one, this transformer is actually like a solenoid. Okay, there is a cutting of the magnetic flux around the secondary coil here. Around the secondary coil here. Okay, cutting of the magnetic flux. Then it will induce the current at the secondary coil produce, and this induced current we will call it as secondary voltage. Okay, so in another words, it's like the flowing, okay, of the current from this part to another part. Okay, from the primary coil to a secondary coil, and is using the force, the concept in what you have learned in 3.2 and the concept you have learned in 3.3 combined together, then it will produce it is working in the transformer. And this transformer only allows AC power supply, okay, to connect it. Okay, so it will increase the voltage or decrease the voltage. Okay, step up the voltage or step down the voltage at the secondary coil. Okay, can Vishnu? Can Kasing? VP is primary voltage. VS is secondary voltage. Primary voltage, secondary voltage. Okay, so if let's say I were to write here, your N is the coil. V is the voltage. Okay, P is primary, S is secondary. No, VP have less than. Okay, Angeline, I want to. This one I write here already. Cousin, I think you can refer to what I've written on the diagram. Just this part only. This part. Okay, this part need to drop. Okay, this part need to drop. Okay, the upper part no need to drop. Okay, okay. Angeline, I want to correct you something. It's not VP VS has less than. It's NP and S. Okay, turn always it will be using N. Okay, okay. Not always NP will be less than NS. It's depending on what kind of transformer it is. Okay, never mind. You all copy first. Later I will explain it clearly. Okay. Can? Okay. Okay, like so let us continue. Okay. So those that cannot make never mind. I will okay, so I just send the this slide inside your note, inside your WhatsApp group, you can refer back to it, okay? Because I want to continue already. Okay, so okay, so type of transformer, just now I said already. Okay, transformer can be either increase the secondary voltage or decrease the secondary voltage, depending on what type of transformer is connected to it. Okay, we have two types of transformer, step up transformer and step down transformer. Step up transformer, it will increase the voltage of the alternating current. Okay, if let's say here, it will be more precise in your secondary voltage. Secondary, okay, voltage. Then step down transformer is to decrease the voltage of an alternating current. Same is a secondary voltage. It is increasing or decreasing the secondary voltage. Okay, how is it you are differentiating this type of transformer? Using the number of turns. Okay, so if let's say it's a step up transformer, you see here, this is the symbol of a step up transformer, and this is a symbol of the step down transformer. Both also is connected to a AC power supply, an AC power supply. Okay, what you can notice here is that you see your primary coil is 3,000. Your secondary coil is 6,000. Okay, 6,000. So which means that your primary coil here, okay, your primary coil is lesser than your, sorry, let me try again. Okay, your coil here, your primary coil is less than your secondary coil. That's why your primary voltage is less than your secondary voltage. So it's less than already, that's why it is stepping up. It is stepping up your secondary voltage. Okay? And how is it happen? Is depending on the coil. Primary coil is lesser than the secondary coil. So for step down transformer, by the way, this one I want you to copy it down as notes number 3. Okay? Together with the symbol as well. Okay? Together with the symbol as well. Okay? So over here, step down transformer, okay? You can see that the number of turns 120. Then here, the secondary is 30. So it shows that for step down transformer, your primary coil is greater than your secondary coil. Primary coil is greater than your secondary coil. That's why your primary voltage, it will be greater than your secondary voltage. Okay, so your voltage is lesser already, man. That's why we will call it as step down transformer. Step down transformer. Okay? Can I? Any problem at the moment? Okay, this one as your notes number 3, yeah? Okay, this one as your notes number 3. Okay, so this one, I think I also will let you have the copy. Okay, so this one I will add in now. It will be the secondary voltage. Okay, secondary voltage. Okay, because I want to continue already, I don't want to let you copy down. You all refer back to your WhatsApp group, okay? Okay, so the voltage of the induced in the secondary output depends on the number of turns on the primary and secondary coil. This is what I have told you just now. So step-up transformer has more turns in the secondary coil, so increase the voltage. Then step-down transformer has a fewer turns on the secondary coil, so it is used to reduce voltage. So that's why I said For step-up transformer, your primary coil will be lesser than your secondary coil because it is used to increase the voltage at the secondary coil there. Okay, for step-down transformer, your primary coil will be greater than your secondary coil. Okay, this is used to decrease the voltage. Okay, so if let's say you see here, your primary coil, you see for step-up transformer, your primary coil is less than your secondary coil. Okay, so you see the voltage is increased from 100 voltage to 400 volt. Okay, 100 volt to 400 volt. Okay, 100 volt to 400 volt. But since this is in the same system, although the voltage is different depending on the number of turns, the power, okay, the power in a transformer, okay, for primary and secondary voltage, it will be the same. Okay, primary and secondary. Okay, I think you just add in one part. Okay, inside your notes there, you write down it will be, okay, the power in transformer is same in primary coil and secondary coil. Okay, NP is primary coil and S is secondary coil. Okay, can I? Okay, clear? No need to draw because before that I asked you to draw the symbol already. The symbol, the number, the notes number 3, the bottom part, the step up and the step down is the symbol of the transformer. So if let's say the question asks you to draw out the symbol of the transformer, that is how you are going to draw. Okay, that is how you are going to draw. Okay, can I? So you see here, next it will be the step down transformer. Step down transformer, you can see that your primary coil is greater than your secondary coil. So the primary voltage will be more than your secondary voltage. Okay, but why is it the ammeter, the current will be different? Okay, remember, transformer is just to increase the voltage. Okay, but the current will be different. Why? Because the power is the same. Then if you are to using the formula, okay, P equals to VI, okay, P equals to VI, okay. When P is the constant, okay, we will use V over here equals to P over I, okay, P over I. In another words, actually, if let's say you put inside the formula, you will realize that the current is different in two parts of the transformer, okay, primary and secondary, and the secondary. Okay, using this formula, P equals to VI to find out the answer. Okay, P equals to VI to find out the answer. Okay, so next, sometimes in transformer, they will ask you to find out the voltage in the secondary current, the voltage in the primary current, and maybe the voltage at the turns at the primary coil and the secondary coil. So you will use this formula to find out the answer. Okay, usually they will give you 3 value. Okay, either is this, then ask you to find secondary, the voltage, the voltage in the secondary voltage. Okay, so this one you write it down as notes number 4. Okay, where VS over VP equals to NS over NP. Okay, you just remember, you just need to know this formula. Then you are able to apply it in any of the question, because the ratio of your primary voltage, okay, the secondary voltage over your primary voltage is the same as the primary coil, a secondary coil versus your primary coil. Okay. Okay, this one also I have dropped down inside your WhatsApp group already. You can refer back to it later. Okay, what you need to do now, you just listen to what am I talking here. Okay, already. Okay. Okay, so for why is it we want to learn about step up and step down transformer? Okay, as you know, our power station, okay, is situated far away from our household, okay, and power station is where we are going to get our electricity, okay, and the electricity is travel in the form of voltage, okay, in the form of voltage. Okay, so we need this transformer since it is traveling in a long distance, to reach our place. So do you think that our the voltage we get from the power supply is enough for us or not? If let's say we didn't step up or step down, it will not enough. Okay, it will not enough. Then that's why we need this transformer to help us to step up the voltage, okay, so that it is transmitted in a high voltage transmission line, okay, because on the way is travel in the in the transmission line, some of the voltage it will be lost, okay, because maybe due to a friction or maybe light energy or what, okay, so it will be lost. That's why we need to step up the voltage first. Then when it reaches, before it reach our household use, okay, as you know, most of our household supply, okay, power supply, we need 20 volt, okay, 100 volt, okay, and if let's say you were to see in this transmission line here, it is very high voltage, so it will be, it will it will rosakkan, okay, it will rosakkan our household supply, household devices, for example, our light and electric and maybe kettle or sofa and so forth. Okay, so we need something to reduce that back the voltage for our household use. That's why we use step down transformer. Okay, so before that is using step up transformer to increase the voltage so that it can travel in the long distance, okay, and is enough voltage for us to use. Okay, but why is it before for us to use we need to step down the transformer, we need step down transformer because it helps us to reduce down the voltage for it to be suitable for us to use, okay, for us to use. Okay, can so what I want you to write down here, you just write down this one can already, no need to draw this one, you just write down this one, okay, write down this part as your notes number 5. You need a step up transformer right after the power plant and step down transformer right before reaches our household. Okay, right before reaches our household. Okay, same as also how to write. You just write the wording can already in one okay, you write like this okay, like this, then like this, then like this, then like this, then like this. Then at the end part you write for house, oh, sorry, house, oh. Anyone can tell me how okay, how much time we left? Less than 1 minute. My God. Okay. Yeah, never mind lah. We stop here already lah. Okay, you stop until here. Okay, next week we will continue back with this transformer. But the question that I've given you in